Hello. Our theme is hydrokinetic turbines in microgrids based on small hydroelectric plants. So this is continues our research papers that I presented before one session. So the main and objectives deals with the problem of enhancing the operational efficiency of microgrids. Based on a small-scale hydroelectric plants, the potential energy of the upper reservoir is converted into kinetic energy, and it is the main problem that this energy is not producing electric energy or getting in another kind of energy. So this energy water flow is usually suppressed in lower pool using wires. So to avoid jailing the river belt, this energy is waste, and the better option would be to increase the power production of hydroelectric power plant using additional hydrokinetic turbines and to suppress the water flow. So small scale hydroelectric power plants currently attracting more global attention in connection with the energy decarbonization. Material and methodologies used for these research papers review of references on top of hydroelectric turbines and was useful for Lithuanian, the biggest hydropower electric powers, ways of using Kaunas hydro turbine power plant is the lower pond to the suppressed power water flow coming out of the main turbines, installation of low power hydroelectric power plants using only hydrokinetic turbines, photovoltaic power plants, and wind power plants. Results, the analysis and discussions, conclusions with the future perspectives. This is the picture of Kaunas region and the hydropower plant. The profile of wave flow damper is shown by the red line on the wall of the HEF wall. So the main idea is that the river will not destroy and crashes. The walls should be protected by the walls. So the possible profile showing on the red line of the water steam bumper building underwater in the lower pool of Kaunas hydroelectric power plants. So unit can be applied in conventional hydropower plants various capacities and where powerful water steams with high risks. So the one of the option is for the simple and for now useful Kaunas hydroelectric power plant, a version of installation of hydrokinetic turbine in a framed riverbed. So it helps it not helps, but it will produce electric energy and will use kinetic energy for electric energy. So this small reservoir can be used for the simple electro plants, and here is the second version of installation. Should be installed for the newest one, but also including photovoltaic or wind electric energy, like a small grid and smart grid system near the hydropower plant. So useful a smart meter and smart programs, the flow of water will be and should be controlled. And the main idea is that the parts, the holes of parts can be useful and for fishes and eutrophication that will be less eutrophication, because when you close the reservoir can be the main problem with eutrophication, and that fishes will not get enough oxygen. So the fish can be migrated when it's opening and when they need it, and of course useful energy from the water to the kinetic. So the main problem is here. We can see what we have in Lithuania. So the main problem, bank of the upper reservoir of Kaunas Hydroelectric power plant. So it's destroyed with the water, and we know that from 1 to 1.5 meters of water evaporates from water bodies yearly. So the main also idea to close the reservoir and maybe to save water can be, could allow about 30-45 millions of water to flow additional through the hydropower plants. So we are also making calculations, and we are getting data from there, and we are analyzing how to solve this problem. So a sufficient number of hydrokinetic turbines used in lower pod or special desiccated hydrokinetic plants allow the kinetic energy of the water flow to be used much more efficiently and friendly. And of course, should be thinking about smart places where can be installed also solar panels, wind power, together, and to take energy from those sources at the same time, because solar panels also thinking about the in reservoir to stay there because of the heating and the cooling system you don't need, and the temperature is always, let's say not always, but the same at the same time will be not changing so much, and the dust, and you don't need to clean and so on. So we also, it's our continuous work with hydrokinetic turbines.
Okay, thank you very much. Do we have questions? Have you estimated, because then you will have, of course, a variation in the power because of the amount of water. Have you estimated more or less how will be the power profile that you will get?
Yeah, yes.
Okay.
It depends, of course, from the time of the year, because we have the lowest part in January and February, because the winter is there. So, and also in the summertime, we are getting data from there, from hydroelectric power.
Okay. Do you have another question?